Hello everyone, welcome to my channel Learning Math with Shelly. In today's session, we are going to work on exercise 3B from mechanics IAL Pearson Edexcel. So here we will be discussing some problems with the vectors using I and J notation. In the last lesson, we learned about what is the meaning of I and J vectors. These are basically the unit vectors in the direction of x-axis and y-axis. Here is the first question. Given that A is equal to 2i plus 3j and B is equal to 4i minus j. So these are the two vectors which are expressed in terms of their I and j components, and we have to find the different vectors, their combinations of A and B using I and j notation. So I am gonna focus on this question number E from here. So E is given as 3a minus 2b, that is equivalent to 3 times of vector A, which is 2i plus 3j, and then minus 2 times of vector B, which is 4i minus j. Now this is gonna be 6i plus 9j minus 8i plus 2j. So I can combine the I components together, which is negative 2i, and then I can combine the j components, which is 9j and 2j, that is 11j. So this is the representation of 3a minus 2b. Now rest of the parts you can do very easily on the same lines. Now we have the second part here, the second question. Given that A is equal to 2 plus 5j and B is 3i minus j, find lambda if A plus lambda B is parallel to vector I. If a vector is parallel to I vector, that means its j component will be 0. And if a vector is parallel to y-axis, that is the j component, then its I component will be 0. So this is the trick we are going to apply in this question. So A plus lambda B for the first part, A part, we have given here A plus lambda B. So A is 2i plus 5j and plus lambda times 3i minus j. So from here I can combine the I components, it is 2, and from here it is 3 lambda. So 2 plus 3 lambda I plus 5 minus lambda, and this is the j component. Because it is parallel to I, that means the j component will be 0. So 5 take away lambda, that will be equal to 0, and from here I get lambda equals 5. Now the second part of this question is mu A plus B. So that means mu is multiplied by this vector. So it will be 2 mu plus 5. 2 mu I plus 5 mu j and plus B, that is 3i minus j. So if I combine the components, it will be 2 mu plus 3i and plus 5 mu minus 1 j. Now here they said it is parallel to j vector, so that means the I component will be 0. So 2 mu plus 3 is equal to 0 and 2 mu is equal to negative 3. So mu will be equal to negative 3 over 2. The next question. Given that C is equal to 3i plus 4j and D is equal to 1 minus 2j, find lambda when C plus D is parallel to I plus j. Okay, so it is parallel to I plus j, and if you see the component of j, like whatever is written here before j and whatever is written here before I, that is 1, so there that is equal. So we will use this technique in order to solve these questions. So first of all, for the first part, it is C plus lambda D. When I have to find the C plus lambda D, so first of all it is going to be C plus lambda D. So I components, if I combine, 3 plus lambda times I, and then plus 4 minus 2 lambda times j. because it is c as it is, and then you will multiply d by lambda, and then you will add the components I to I and j to j, and you will get this result. Now because it is parallel to I plus j, so I component is exactly equal to j component. So I will say 3 plus lambda is equal to 4 minus 2 lambda, which is going to give me 3 lambda is equal to 4 take away 3, which is 1, and that means lambda is equal to 1/3. Then the B part of this question is mu c plus d. So first I will form this mu c plus d. I am doing it directly. It will be 3 mu plus 1 I, and then plus 4 mu and minus 2, that is j component. Now this is parallel to I plus 3j. So what I see here, that j component is 3 times of I component, right? Here j is multiplied by 3 and I is 1. So j component is 3 multiplied by 3, or what I can say here, that j component, and so the j component is 3 times here given, with the I component is used only 1 time. So using that one, so j component, when I say j component, so j component of my vector is 4 mu minus 2, that is equal to the I component. So 3 mu plus 1. So from here 4 mu minus 3 mu is equal to 2 plus 1. 4 mu minus this is equal to 3 times of. We have to use this part, that j component is 3 times of this one. So 4 mu minus 2 is equal to 9 mu plus 3. So 4 mu minus 2 minus 3 is equal to 9 mu minus 4 mu, which is 5 mu. So 5 mu is equal to negative 5, and that gives me mu is equal to negative 1. Now we go to the next part of this question, which is question C of question number 3. So they said C minus SD. So 3 minus SI plus 4 plus 2SJ. This is the question here I formed. Now what they say, it is parallel to 2I plus J. So what I can see, I component is twice of j. So I component is twice of 4 plus 2s. You have to say it like this. I component is 2 times of this j component. Okay. So 3 minus s is equal to 8 plus 4s. And when you solve it, it will be minus 5 is equal to 5s. And s is equal to negative 1. Then we have this was the C part of the question. Now we are focusing on the D part of the question. So what D part says, D minus TC. So 1 minus 3TI plus minus 2 and minus 4tj, and this is given as minus 2I plus 3j, or I can write minus 2/3 of I plus j. I can write it in something like this. So I component is, the I component is negative 2/3 of the j. Okay, so I component is 1 minus 3t, and that is equal to negative 2/3 of the j component, which is minus 2 minus 4t. Then you can multiply 3 by 1 minus 3t, and other side is minus 2 times minus 2, which is 4, and minus 2 times minus 4t, that is 8t. So 3 take away 9t is equal to 4 plus 8t, and that gives me minus 1 equal to 17t. So t is negative 1 by 17. So in this question, what is special when you are looking at this one? So I component is twice of the j component. We have used I component as twice. So whatever is I here, it should be 2 times. Okay, so we will write, okay, this is twice and this is once. We will do like that. So this component we have to use like, okay, this component is twice. Next is the horizontal unit vectors I and j are directed due east and the north due north. Find the magnitude and bearing of these vectors. So we have 2i plus 3j. If you represent this vector in general, so let's say this is the origin, 2i plus 3j is somewhere here, because you will go 2 steps here and then 3 steps here, so you will reach here. So basically the vector is going this way, and if you have to find its bearing is an angle made by the north line from the beginning, and this angle you have to find out. So this angle you have to find out. Let's say this angle is theta. So our answer is, let's say, theta 1. So theta 1 is equal to 90 degree. That is this complete angle 90 minus this angle theta. So how to find this theta? I will say tan theta is equal to 3 divided by 2, and theta is equal to tan inverse 3 by 2. So I got 90 take away tan inverse 3 by 2, which gives me 33.69 degrees, which is approximately like 34. And because it is a bearing, so we have to give it as a 3-digit number, so 034 degrees. Second part of the question is 4i minus j. Now I component, that is to the east direction, j component is to the north direction, but j component is negative. So how we will draw it? It is like origin here, the B question, 4 units to the right and 1 unit to the left. So basically the vector is something like this, and with the north I have to see its direction from the north. This is the angle. So here what is formed, if I continue this way, this is 4 and this is 1. I need to know what is this theta, and then I will add that theta to this 90 degree angle. So our answer is, the bearing is 90 plus this angle theta, and to find theta I will say tan theta is equal to 1 by 4, and theta is tan inverse 1 over 4. So theta is equivalent to, so whatever is the value of theta, that will be added here, and when you will add 90 plus tan inverse 1 by 4, you are going to get an answer 104.036 degrees, which is like 104 degree. It's already a 3-digit number. Then if you have to solve the next question, which is minus 3 plus 2j, minus 3i plus 2j. So minus 3i, this is the origin, minus 3i going to the left, then 2j, that is up. So it is something like this. Now we have to find the angle with the normal, and it is in the clockwise direction. So basically I need to find this complete angle. And if you see up to this point, this whole angle, this is 270, because it is like what, this is a vertical line and this one is the horizontal line. So this is 270, 3/4 of the whole circle. And then we have to find out the extra angle, and I am considering that angle is to be theta. So my answer will be 270 plus this angle theta. In this case, tan theta is equal to 2 divided by 3. So theta is equal to tan inverse 2/3. So I will say the bearings is 270 plus tan inverse 2/3. That is going to give me an answer of 303.69, which is 304 degrees to the whole number and as a 3-digit number. Then we have the next part of our question, that is part D, and that part D is given as negative 2i minus j. Negative 2i minus j. So if I have to draw this one, so first I start from the origin, negative 2 in the left direction, that means 1 in the down direction. So it will be something like this. Again bearings, that means we have to draw the north at the starting point, and from here in the clockwise direction I need to go until this line. Now this angle is less than 270. How much less? This much less. Let's say this is theta. So bearing is equal to 270 minus theta, and this is 2 and this part is 1. So this is 270, and tan theta is equivalent to 1 over 2. So theta is tan inverse 1 over 2. So minus tan inverse a half, and that's going to give me an answer of 243.43, which is approximately 243 degrees in the form of bearings. And also in all these questions you need to find out the magnitude also. Magnitude is very simple. You have to find out the square root of I component square, so that is 4 square if I focus on the second part, plus minus 1 the whole square. So that is 16 plus 1 17, so it is square root of 17. This way you can find the magnitude of question A, C and D. And this video now completes exercise 3B. Thank you.